Good afternoon, everyone. Hello, hello. Good afternoon, everyone. Here we are in the second session of FDP Industry 4.0. We have very renowned Dr. P.K.P. Rupa, Professor, Associate Professor in the Department of Material Science and Engineering, Tripura University. Dr. P.K.P. Rupa is presently working as an associate professor in Department of Material Science Engineering. He has worked in the areas of thin films, thermal spray, hydrogen storage materials and devices, intermediate temperature solid oxide fuel cell. He is currently working on direct ink writing via additive manufacturing. He has published over more than 13 SCI journals. So I request Dr. P.K.P. sir, please start your presentation by today.
Okay, thank you for the introduction and good afternoon to everyone. So let me start my presentation. Evolution of surface coating techniques. Okay, when your HOD sir actually invited me to give this talk, on Industry 4.0 evolution, I was thinking, what should I give? Okay, because normally whenever you want to give a talk, usually it is based on your own experience. Okay, the fields in which you have worked already, and that will put you in a comfortable zone. Okay, and when Industry 4.0 was the topic, then I said, okay, it is not my zone of comfort. I mean, I'll give a disclaimer before itself. It is not my zone of comfort. But then I thought, okay, it is a challenging talk. And during the presentation, okay, I had to prepare read a lot of things, and it was a discovery for me itself for a lot of things. Okay, so I thought, okay, since technology is continuously evolving, and I've been involved in surface engineering, okay, so I thought, okay, let me just make it evolution of surface coating techniques and how it is actually useful in Industry 4.0. Okay. So the outline of the talk will be Industry 4.0, historical context, technology drivers, Industry 4.0 and its relevance to India, materials and Industry 4.0, case studies, and in the case studies, plasma spray, cutting tool industries, and sensors for the industry. Okay, so this is the outline of my talk. So what is Industry 4.0? So Industry 4.0 is a combined, integrated and seamlessly connected network of machines, product, processes and manufacturing systems. Okay. It is a general manufacturing enterprise with a physical product at the core. So you always have a product in mind when you want to do something. Okay. It is not something which is abstract. It is something which is physical, which is real. Product in mind and driven by the information of an integrated information network among the internal stakeholders, that means the people who actually are in the process of making a product, as well as external entities such as customers and suppliers to whom they are making. For example, if I am the customer, there is a product person and he is actually making it for me. And in this process, what is most important is digitization. So the digitization of the physical assets and manufacturing activities. Digitization, for example, if we want to know how many ACs are in the room, okay, at the click of a button, how many fans are there, how many lights are there, that means every aspect of the industry that you have, asset, okay, because these are all assets of the institution. So these have to be digitized in various forms. Okay, why they have to be digitized? What is the biggest advantage you get by digitization? Yeah, students, why assets have to be digitized? What happens if you don't digitize it? Okay. Huh? Okay, any example of a digitization? Okay, I'll give you an example. Suppose 20 years back, 30 years back, if you lose your mark sheet, as simple as that. Okay, you lose your mark sheet. Okay, You have to go to the police station, give a police complaint. Then you, if you are in Tripura board, if, for example, for me it is CBSE board, I have to go to the board, write a letter. I don't know when I'll get my certificates back. In digitized form, you lose it, it doesn't matter. You have in your mobile, you have it in your laptop, okay? You can give it wherever you want. So the digitization has its own tremendous advantages, okay? So digitization of assets and manufacturing activities along with the network of digital communications will fundamentally change the manufacturing industry landscape, okay? And end-to-end digitization will improve process efficiency, quality management, productivity, along with real-time insights into the whole manufacturing landscape. Okay, so this is what is the broad definition of Industry 4.0. Different companies have different definitions as per their own needs. Okay, for example, if you want to define Industry 4.0 as per your own requirement, you can do that. Okay, so it is basically a platform, you can say. Historical context, I think some historical context was given by the Vice Chancellor in the previous talk. So the first context, the transition from foraging to farming, okay? Man was actually a nomadic animal. He used to forage for his food. And from forage to farming, that happened about 10,000 years ago. And it was made possible by domestication of animals, okay? So what the nomadic life was actually changed to the place where man was actually living at a certain place and then working for his living. The agrarian revolution was followed by a series of, so the first revolution was agricultural revolution, followed by a series of industrial revolutions that began in the second half of the 18th century. So the first revolution, industrial revolution. Now we are not talking about the agricultural revolution. We're talking about industrial revolution. It spanned from 1760 to 1840. It was basically triggered by the invention of steam engine and mechanical production of items. The second industrial revolution, which started in late 19th century and early 20th century, made mass production possible and advent of electricity and also assembly line. Okay. So in the previous case, suppose if you want to make a car, you will all make an individual product. But which was the first company which made assembly line for car? First company which made an assembly line for car out of Toyota, US company, Ford. Okay, so Ford was the first company which actually made an assembly line for cars. Okay, and what is the reason for extensive road network in USA rather than rail network? India has an extensive rail network, right? It is only now that we are having road networks. But what is the reason for USA to have road networks, not rail networks? Assembly line of cars is the reason. Okay, yeah, it is the reason because they didn't want rails because people will use trains. Okay, they wanted people to buy cars, and to buy cars you need roads. Okay, so they invested in roads, they invested in roads. Okay, so development of a country is often dictated by, okay, yeah. So assembly line was the second revolution, and the third revolution, which actually started from 1960s, advent of semiconductors, mainframe computing, and personal computing and internet. All these are the last, 1960 to about 2000. These technologies have come about. Okay, and the fourth revolution is in the century is built in the digital revolution. So whatever you are actually seeing here, okay, development of semiconductors, it's an ongoing process. Mainframe computing, personal computing, and internet. These are all there now also. Okay, but what is the difference between third and fourth revolution is the speed with which you can actually access the data. Okay, any reason why GPT, everybody knows about it, right? Okay, why it has come about last year when the technology, I mean, the know-how was there 10 years before. OpenAI, okay, artificial intelligence, machine learning, these were there 10 years before also. But why it has come about last year? Any idea? Yeah, this side also. Because Hmm. So what is required for that solution to be given in a readable format? Huh? Generative AI. Okay. Generative AI was there 10 years before also. Generative AI, no, see the technology, the know-how, the theoretical aspects I'm telling, was there 10 years before also. Okay. But why it has come now is because of the advancement in computing power. You are able to process information much faster. Okay, it will take 1 day, 2 days. Why would you give a command to the chat GPT? I want this answer. If it take 2 days. Okay, in my like I had my first personal computer in 1998. Students were not born, I think, by that time. Okay, I used to switch it on 20-30 minutes के बाद वो on होगा. Yeah, word को click करो, आधा घंटा के बाद word आएगा. So I mean, if that is the kind of processing that is speed. Now you just have a mobile phone, you can open whatever you want within a fraction of a second. Okay, so the computing power and is what is actually aiding the speed with which you can actually compute. Okay, is what is aiding with the current digital technology revolution. Okay, so the fourth industrial revolution is not only about smart and connected machines, its scope is much wider. Okay, and in this fourth industrial revolution, we have breakthroughs in other areas also. Okay, for example, gene sequencing, nanotechnology, renewables, quantum computing. Any idea what is quantum computing? Or what are quantum computers? Or what advantage it is supposed to bring? Yeah, if you can say that the world's fastest supercomputers, which are in work today, okay, if you can say that they are 1 lakh times faster than the supercomputers, okay, so you can imagine the kind of technology revolution it will bring. Okay, that is about quantum computing. Okay, I mean, when I was doing my MPhil, that is about 25 years back, my sir, who already did PhD and was already teaching, okay, told that his guide in USA was working on quantum computers. So it is 60 years of work that is actually going to take place. And in 2017, were the first quantum computers actually came to the industry. Okay, and people are still not selling it because why they are not selling it? Okay, suppose if you have a banking password, okay, it is usually stored in what kind of a format? 128-bit, 256-bit, right? Okay, so you can try 100 iterations, 1,000 iterations. To crack a banking password, you would require at least more than 1 lakh iterations. Okay, but with a supercomputer, it is a click of a button. Okay, so it has tremendous what to say applications in lot of areas like banking. You can even crack passwords. Not a possible, but at the advantages, weather computing, all those things will be very advantageous using quantum computers. Okay. So what are the technological drivers for the fourth industrial revolution? Everything should have a driver. Okay. There should be a motivation. So there are three drivers: physical, digital, and biological. Physical is, for example, autonomous vehicles. You have driverless cars, drones, 3D printing, additive manufacturing, advanced robots, and new materials. Digital is the mix of these physical and digital applications, basically Internet of Things, and how you actually relate between human and machines. Okay. The fourth industrial revolution is all about interactions of humans with machines. Okay. For example, I'm not comfortable with this, but I have to learn with it. Okay. So I have to learn how to deal with machines for my own betterment. Okay. That is what is digital relationships are all about. And then this would require a tremendous amount of improvement in sensors. Okay. sensors and other numerical connecting things with the physical world with the virtual networks. Okay, and terms like blockchain, cryptocurrency, data analytics, they are all part of the digital. And finally, you have biological, genetics, synthetic biology, medicine, cancer cure, 3D manufacturing will actually combine genetic editing with tissue engineering. Okay, that is what is now called 4D printing. 4D printing is, just imagine you can print a heart. Just imagine you can print a liver. Okay, so studies are actually going on to club 3D printing with biological systems. Okay, for example, the latest development is printing of artificial skin. People are able to print skins, okay, which will actually be used in medical purposes. Genetics, human genomes, for example, the first genome, when the entire code of the human being, it took about $2.3 billion project spread over some 15 years. Okay, that is the kind of time and that is the kind of money that is required. Now human genome can be done with $1,000. Okay, where is $2.3 billion and where is $1,000? You can get your all, genetic genome done with as little as $1,000. Okay, so these are all possible because of the fourth industrial revolution. Okay, and have you heard anyone heard about designer babies? Designer babies. What is it? Designer baby. Yeah, yeah. You put the taller gene in that one, and that baby will become taller. Okay. So all these kinds of things are actually possible. Yeah, they are technologically possible now. Okay. So what is stopping people from doing that? Yeah, the law is actually stopping. Okay, government is not giving permissions to do such kind of things. Okay, in agriculture, for example, you heard about this BT brinjal, right? Okay, so they are all examples of genetics, synthetic biology, and it has advantages also in medicine, cancer cure, etc. Okay, so drivers, all these terms you have to get familiar with. Internet of Things, cloud computing, AI and machine learning, edge computing, cyber security, digital twin, big data, augmented reality, additive manufacturing, autonomous robots. Okay, all these are actually in fourth industrial revolution. Now, what is industry 4.0 is not something which every industry will follow. They have to develop their own policies for industry 4.0. Okay, for example, it is a political vision than a technological paradigm. Okay, that means the 4.0 of Germany is different from 4.0 of Japan, is different from 4.0 of India. Okay, so every country has to adopt the norms of industry 4.0, but what is common in 4.0 is the digitization of knowledge. Knowledge is no longer confined to the individual. Okay, whatever knowledge I have gained through years of experience, I have to put it in a machine, somebody will immediately come and access it. Okay, so is it an advantage or a disadvantage? Yeah, for me it is a disadvantage. Okay, what I've heard, with my hard work, I'm losing it. Okay, I had a friend who was in GE. He worked in GE for almost 15-20 years. Okay, so he acquired a lot of knowledge, and finally, industry 4.0, GE thought of implementing it. Then what has happened is, whatever he has gained, they all asked him to put it in paper. Okay, so finally he realized that my days in this company are counted. Better I start searching for a job, and if he's lucky that he got a new job. Okay, so there is an advantage and there is also a disadvantage. Okay, so companies are at an advantage because of industry 4.0. When it comes to humans, there are some question marks. Okay, yeah. Now industry 4.0 with reference to India. Okay, the government has a policy called DESI. Okay, so what is this DESI? D is for digital revolution, E is for entrepreneurship and ease of doing business, S is for startup ecosystem and skill development, and I for innovation and India first. Okay, so this is what I mean, so the government policies are with respect to this Desi formula for industry 4.0. Okay. So what is D? So D is basically bridging the digital divide between India and Bharat. What is India and Bharat? Are they synonyms? Are they same? Are they different? Huh? Why India and Bharat? I have borrowed this statement from somebody. Okay. The reference is given. But why India and Bharat? India is supposed to be more cosmopolitan, rich, okay, yeah, modern, people who can afford, people who can afford technologies. Whereas Bharat is more middle class, people who live in villages, okay, where technology is not affordable, okay. So there is a digital gap between the people, rural India and the urban India. So this D is trying to bridge the digital divide between India and Bharat. Okay, so that is the first thing. And secondly is to democratize technology. Okay, democratize technology. For example, you have this direct debit transfers, right? Heard about DBTs? Direct debit transfers. Money is directly put in your bank account. Okay, so it is basically democratization of the technology. You have a technology, you're using it for the betterment of the people. No corruption, you're eliminating middlemen. Okay, and this will ensure transparency, accuracy, and efficiency. Okay, and democratization of digital technology has led to adaptation of communications and delivery and payments. For example, UPI is an example of democratization of technology. Okay, E stands for entrepreneurship and ease of doing business. How many of you would like to be entrepreneurs? Yeah, anyone who wants to start his own business, wants to be an entrepreneur? Okay, so there are bottlenecks if you want to be an entrepreneur. Okay, so what are those bottlenecks? Government should actually play a role in removing those bottlenecks, whatever they may be. Okay, so and the third one is encourage entrepreneurship by creating special funds. If you have heard about this budget this year, okay, there is going to be a special fund Anusandhan scheme. Okay, with a corpus of 1 lakh. Government is ready to distribute money, 1 lakh crore. Okay, if they give me, I'll take 10 crores happily. Okay, so be ready. I mean, the kind of money which government is putting in these efforts, okay, will see light at the end of the day. People will make, people will become entrepreneurs, and some of them will actually utilize this money to grow big. Okay, so this is the E. Skills, startup ecosystem, skilling up is all there. Yes, which is a continuous process. And research and innovation as a way of living. Okay, so we have to be a research nation. Have you heard about this book, Startup Nation? Have you read the book called Startup Nation? Which is the startup nation, so-called startup nation of the world? Small country, Israel. Okay, Israel is supposed to be the country which has the largest number of successful startups. Okay, China, I always have doubt. Okay, but there is a book by this name. Okay, Startup Nation. Okay, where they discuss in detail about the country of Israel, which has actually gone about, improving technologies. Okay, so I is about research and innovation. So in this one, all these policies will come. India First policy, Make in India, Atmanirbhar Bharat, PLI scheme and PLI scheme for mobile manufacturing and also for semiconductor fab manufacturing. Okay, how much money is coming into India for this semiconductors? कितना पैसा आ रहा है इंडिया में? 4.3? Yeah, you're right. How much is coming into Assam? 1/3 of that money is coming into Assam. Okay, so as a northeastern state, we should be very happy that that kind of money is actually coming into Assam for making semiconductor fab manufacturing system. Okay, and in the Indian context, okay, India is currently at $3 billion in manufacturing. Okay, and we have about 15% of that share is basically from manufacturing. Okay, that comes to about $450 billion. In a few years' time, we will be 5 trillion economy. And if we are the third, which is the largest economy? USA. Second, third, huh? India is currently, what is the rank of India? Hmm. Germany, China, USA are above us. Okay. So India is currently fourth. Okay. So in the next couple of years, we are trying to overtake Germany. Okay. So China will be second, USA will be first. And when that happens, 5 trillion, approximately 1.25 trillion will be the manufacturing. Manufacturing money a lot has to do with engineering. Okay. So engineering is bound to grow in India. These are not my numbers. I'll be very happy when all my students get jobs in industry. Okay. I always want that. But these numbers, this is going to happen soon, next 5 years, within the next 5 years. Okay. So be ready, I would say. If India becomes even a $10 trillion economy, that is the projection in the next 10 years. Okay. So the kind of money that is expected to come from manufacturing is huge. 3-4 trillion dollars. Okay. That is going to be very large. So opportunities are there. Okay. Lot of it. And being a materials engineer, as I already told you, industry 4.0 is about your own way, how you think about making changes in the policies. Okay. So materials is going to play a major role, or engineering, you can say materials engineering is going to play a major role. Okay. Because of the rapid changes in production methods, efficient and appealing products, we don't want, you know, products which don't look good. Okay. So we want them to be good, and they're all manufactured by sustainable processes. This is what industry 4.0 is about. And the focus is on advanced materials, structural materials, and functional materials. Okay. For example, energy, electronic devices, biomaterials, nanomaterials, materials for transport and aerospace industries, and additive manufacturing, surface technologies, joining techniques. Everything is going to change in industry 4.0. Okay. So mechanical and materials, yeah, a big thumbs up. Okay. Things are going to change. Now, if we are in smart materials, okay, so advanced materials like, for example, shape memory alloys, new smart materials, for example, these carbon nanotubes, graphene, okay, they are all coming into play with various self-healing materials, self-repairing, self-repairing what do you say, polymers. Okay. For example, a lot of these coatings are actually coming up on these windshields of cars, where if somebody tries to scratch your car, okay, the paint will heal itself. So self-healing paints. Okay. So they are all actually smart materials which will understand the requirement and behave accordingly. Okay. So there is going to be a huge revolution in smart materials also. This is just an example. Okay. Graphene based heater jacket. You can design clothes. Okay. Based on materials. So I mean, these two are the people who actually made this graphene based coats, which can actually heat up in winter locations. For example, if our soldiers are in, fighting in Tibet, Himalayas, okay, you can give them these jackets. They are flexible, AI operated, graphene based, electrical insulating, multi-layer, lightweight. Okay. All these are clubbed into making a useful jacket for the army. Okay. And this is brought about again by the improvement in materials and also AI. Okay. So this is integration smart networks. Okay. Because whenever you think about digitization, you always need some sensors which can actually make digitization possible. Okay. So you have the smart sensors which actually play a very important role. You have to develop sensors that is which can actually take the data and then convey it to the network. Now we'll just see few case studies, okay, about industry 4.0, how it is applied in specific industries. Evolution of plasma spray, okay. This is a family of thermal spray. What is thermal spray? By the way, I'll just explain. You have seen these oxyacetylene torches, okay. So assume you have an oxyacetylene torch, okay, which is the flame temperature is about 3000 degrees, right? Okay. When the flame, you put your particles which you want to coat. It can be polymers, it can be metals, and the powder particles will get heated up, okay, and the flame is always moving forward, right? So it has a momentum. So that momentum is transferred to the particles, and when the momentum is transferred to the particles, you put any substrate, it will get coated, okay. So this is basically a coating technique, okay, which uses the heat. So you have a detonation gun, HVOF, wire arc spray, frame spray. These are all the family of thermal spray systems, okay. So this is a typical, you can say, picture cross section. This is your cathode, this is the anode, this is connected to a DC power source. An arc is struck between the anode and the cathode, okay, and arc temperatures are very high. And if you pass argon gas, whenever there is an arc, the argon gas will ionize, okay. And when there is ionization of the argon gas, you this is the powder feeder where the powder particles actually fall into the plasma. The temperature of this plasma is about 15,000 K, the highest that you can actually get in thermal spray, okay. So the temperatures are very high. Virtually any material can actually be melted using plasma, okay. Which is the highest melting point metal? Yeah, tungsten, very good, very happy. What is the temperature? 3300, okay, 3300 degrees C. It is the only metal which is having a higher temperature of 3300, okay. There are certain ceramics also, and those ceramics are actually called ultra high temperature ceramic materials, okay. So even those ultra high temperature materials can actually be used for melting the powder particles, and eventually what will happen is, yeah, I'll show here. I'll come back again. Okay. So the powder will fall into the plasma plume and it will get incident on a substrate and it will form a coating. Okay. So in this process, a lot of preparation has to be taken place. You have very high power and then you have very high output of temperature, the gases. Okay. The particles are moving with a velocity of about 610 meters per second. So this, with these kind of parameters, you as an engineer who is doing this, you have to note down all these things, okay. So when we were doing, we have to note what is the argon, what is the hydrogen, how much should be the distance. We used to record everything in our logbook, okay. Now when you actually do a product, okay, the first is you have to clean the surface for a coating. Any surface, I mean, for any coating, you actually clean the surface, okay. You clean the surface, you have to use grids, grid blasting. So what are all the grids that you actually use? What are the materials that you use? What are the process that you actually do? So everything is actually noted down, okay. Yeah. Now when you actually do a coating, okay, as I told you that the particles will actually fall onto the plume and they get incident and fall on the substrate. So each of these particle will actually be in a molten state, and that particle, when it actually falls on the substrate, then it is called a splat, okay. So each of these is actually a ceramic particle that has actually melted, and when it is on the substrate, it has become flat, okay. So you have to see at what temperature you can actually get a very good coating. So all these data that you actually generate, this data is actually generated by a series of experiments, okay. If any new material is given, you have to do all this study to find out what actually you actually the parameters are the most convenient, okay. And after doing this, these are some of the components which we did, okay. This is the stage 2 compressor disc of a gas turbine engine with a coating of tungsten carbide cobalt and also Ni328. It is a nickel based coating. Of course, I mean, these are all some of the aerospace components that we actually did by plasma spray, okay. And for textile and paper industry also, if you get any component, for example, okay, so the first job is, yeah, sometimes you may have to develop jigs for coating, okay. So if you have to do something coating, then for example, if we got this 2 meter by 20 mm, what to say, cylinder, which had to be coated with a specific material. So you have to, what is the RPM that should be given to this? What should be the traverse speed? What should be the parameters? After this, the specification of the customer who says that the roughness should be less than 5 micron. So we have to, after that, we have to do a grinding process also to get the specific requirement of the customer. Okay. So all these process which are actually acting as an input, okay, are stored in my mind because I am actually doing this. But now in industry 4.0, you don't want that. Okay. What you actually do is, yeah, just a minute.